Come and join iLearn IAS and feel the difference.
Hello everyone, my name is Nikhil. I am Geography faculty at iLearn IAS. In this session, we shall be discussing one of the most important topic in physical geography, that is geomorphology. Now, before getting into geomorphology, I'll ask you a question. The question is, why civil servant or IAS officer should study physical geography? Now, if I answer that particular question, my answer is, it is the physical geography that gives us comprehensive understanding with respect to a country's resources, country's landscape, country's opportunities and challenges. It is the physical geography that actually decides the food choices, the life and livelihood of people of a country. See, if you analyze the importance of physical geography, you can see the importance of physical geography in almost all aspects of life. It is a physical geography that decides what we eat. It is a physical geography that decides what we wear. Why Indians eat spicy food? Why Russians drink a lot of vodka? Most of the reasons, answers are hidden in physical geography. And as a civil servant, or as a IAS or IPS officer, as a civil servant, if you are heading paramilitary forces, how will you understand India's vulnerability without understanding physical geography? For diplomatic negotiations, for understanding the internal security issues, all are actually relied on physical geography, right? Suppose you are heading Urban Development Ministry or Ministry of Agriculture, right? It is the knowledge in physical geography that help us to or help you to solve important issues with respect to urban development or agriculture. You should have knowledge with respect to soil, land degradation, land resources, etc. So it is very important for a civil servant to have a comprehensive understanding with respect to physical geography of the country. Now, if I talk about the importance of geography, see, geography can actually make civilization powerful. Geography can make a civilization most innovative. If you analyze the important civilizations, if you look at the important civilizations like Egyptian civilization or Mesopotamian civilization or Indus Valley civilization, Egyptian civilization, River Nile, Indus Valley civilization, River Indus, Chinese civilization, you have Yangtze River. So all these civilizations were actually around what? These rivers. So that means physical geography can actually what? Can make a civilization powerful, the most powerful. Physical geography can actually help civilization most innovative. For example, if I talk about rivers, we say that rivers are arteries of trade and transportation, right? So now if you look at the transportation network, we have roadways, railways, airways, waterways. But previously, it is basically the rivers. It is along the rivers that we have major percentage of transportation occurs over rivers. So it is the understanding of physical geography, or it is a study of physical geography that helps us to understand, to appreciate diversity of a country, right? Now, the study of physical geography or study of geography starts with understanding of Earth's surface. The study of physical geography starts with the understanding of Earth's surface. And what is that understanding of Earth's surface? The understanding of Earth's surface is nothing but geomorphology. So what is geomorphology? In geomorphology, you are trying to understand the different physical features, the landform features on the Earth's surface, right? So in geomorphology, it is basically, if you look around you, you can see different mountains, plateaus, plains, valleys, deltas, rivers, etc. Study of these physical features of these landscape, it is nothing but what? Geomorphology. So geomorphology is the study of relief features on the Earth's surface. So one of the most important term which is coming up, it is called relief features. So the study of geomorphology starts with study of relief features, right? Now in geomorphology, you need to understand what is a relief feature, what are the different types of relief features which you see on the Earth's surface, how these relief features are formed, by what process they are formed, at what time they are formed, and the characteristics of these relief features. So that is what we need to study in geomorphology. Now this particular topic, geomorphology, is important for prelims examination as well as mains examination. You'll be getting questions in prelims as well as in mains. So let us start with relief features. If I talk about relief, relief is any physiographic feature which you see on the map of world. Any physiographic feature which you see on the map of world, it is called relief feature. Now, carefully understand what I'm saying. These physiographic features or physical features on the map of world, for simplicity of understanding or for systematic understanding of these relief features, we classify these relief features into orders of relief. Into orders of relief. So what are relief features? Relief features are nothing but physiographic feature which you see on the map of world. That means if you open a world map or Indian map, or if you look around you, you can see physical features. What all physical features you can see? You can see mountains, plateaus, plains, valleys, rivers. All these are glaciers. All these are physical features, right? So study of or these physical features are called relief features. So in order to have a systematic understanding of these relief features, we classify relief features into orders of relief. So what do you mean by this orders of relief? Orders of relief means we have 3 orders of relief. That means first order, second order, and third order. First order, second order, and third order. Now what is this first order relief? First order relief means if you take an aerial view of Earth's surface, you're actually looking the Earth from a particular height, from above. What you can see? You can see some blue patches. You can see some brown patches. What are these blue patches? Blue patches, nothing but water or oceans. What are these brown patches? Brown patches are nothing but land, right? So if you take an aerial view of Earth's surface, you can see land and water. So this land and water, it is called first order relief. So first order relief is defined as macro division of Earth's surface into land and water. You are dividing the Earth's surface into land and water. This is called first order relief. So land is called continent crest. Water is called oceanic crest. We'll come to these technical terms later. What is this continent crest? What is this oceanic crest? Not right now. For the time being, just understand continent crest is land, oceanic crest is water. You are actually dividing, you take an aerial view of the Earth's surface. You can see 2 brown patches and blue patches. What are these brown patches? It is nothing but land. Blue patches is water. This is called first order relief. Now, what is second order and third order relief? Now, one thing you need to understand is I talked about landscape. Physical features or physical geography help us to have a comprehensive understanding with respect to landscape of a particular country. Landscape is nothing but the visible feature or visible feature of area of a land. That is called a landscape. Now, if you take the landscape, it is like, for example, mountains or plains or valleys, etc. Any relief feature or any landscape which is formed on the earth's surface is actually due to two important forces, right? If you look around you can see mountains, plateaus, valleys, rivers, etc. Different landscape or different relief features you can see. These relief features are actually nothing but are the resultant of two important forces. What are these two important forces? Two important forces are, one is endogenic force, two is exogenic force. Endogenic and exogenic. What I'm trying to say is, see, if you take any location, for example, Delhi you see today were not like this 100 years ago. Or if I take example of Dubai was actually what? A desert with a lot of sand dunes 50 years ago. Now they have actually created artificial islands over there. So any landscape is actually what? They were not like this yesterday. Yesterday means like 50, 100 million, 50, 100 years ago. Understanding it? So what I'm trying to say is, the present world map or present Indian map which you see today, if you open up world map or Indian map, you can see so many mountains, plateaus, plains, etc. So many relief features you can see. These relief features were not like that, like you see it today. It is not like this, what, in the past. Understanding it? For example, I told you Delhi, the place Delhi is not like this, what, 50, 100 years ago. So what I'm trying to say is, any relief feature which you see on the map of world or map of India today is actually how they are formed. They are actually formed due to two important forces. The first force is called endogenic force, second force is called exogenic force. We will try to understand the detail of what is endogenic, exogenic forces. So you need to understand one thing: any relief feature which is there on the earth's surface is the resultant of action of two important forces. One is endogenic, two is exogenic. Right? Now, if I talk about endogenic force. Endogenic force means forces which has got its origin within the earth's interior. Understanding it? Endogenic force means, I'm talking about endogenic force. Endogenic force means force which has got its genesis, origin within the earth's interior. It is called endogenic force. For example, earthquake, volcanism, they have got their origin within the earth's interior. So such kind of forces are called endogenic force. So what these endogenic forces will do? Endogenic force has got its origin within the earth's interior. They will come out to the surface and they make some changes or variations. They make some changes or variations on the earth's surface. Understanding it? So what we are actually discussing? We are discussing about relief features Relief features is nothing but any physiographic feature which you see on the map of world is called a relief feature. For simplicity or systematic understanding of relief features, we classify it into orders of relief: first order, second order, and the third order. What is first order? You take an aerial view of Earth's surface, you can see brown patches and blue patches. It is called the first order. We call it as land and water. Land is continent crust, water is oceanic crust. Now we are discussing second order and third order. Before that, we actually give ourselves a reminder with respect to the fact that any relief feature or any landscape which you see on the map of world or map of India today is basically the resultant of the action of two important forces. Which are those forces? One is endogenic force, other is exogenic force. Let us understand what is endogenic and what is exogenic. Endogenic force means forces which has got its origin within the Earth's interior. So what they will do? They will come out to the surface. They will come out to the surface. They will produce, or they will actually develop variations on the surface. If I talk about earthquake, flat area can be converted into a twisted area. Right? Flat area can be converted into a twisted area. Earthquake can actually reduce the height of a particular relief. So many destructions happens on the Earth's surface. Understanding it? So endogenic force develops variations on the Earth's surface. That is the reason they are called variability developers. They are called variability developers. Right? Now coming to exogenous, how many endogenic forces we have? We have three important endogenic forces. One is earthquake, two is volcanism, three is mountain building. These are the three endogenic forces which you need to study: earthquake, volcanism, mountain building. So endogenic forces have got its origin within the Earth's interior. They will come out to the surface. They develop variations on the Earth's surface. They are called variability developers. How many endogenic forces we have? We have three endogenic forces: earthquake, volcanism, and mountain building. Right? Now coming to exogenic forces. What is exogenic forces? Exogenic forces are engaged in leveling task. Exogenic forces are engaged in leveling task. They will level the land. Level the land means, suppose there is a high land and a low land. High land means mountain, low land is plain. So what the exogenic force will do? Exogenic force will level. Level means erode this mountain, and this eroded material will be deposited on the plain, so it will level the land. Understanding it? So that means exogenic forces engaged in threefold task. Exogenic forces engaged in threefold task. For example, river is an exogenic force. What river is doing? River will actually originate from a particular mountain. River will erode that particular mountain, carry the sediments along with it, deposit in the plains. Understanding it? So that means river is actually engaged in what? Leveling task. That is the reason exogenic forces are called levelers. They are called levelers. Exogenic forces, levelers. Endogenic forces, variability developers. So what is the threefold task done by exogenic force? It is erosion, transportation, deposition. Erosion, transportation, deposition. If I take a river Ganga, originating from Himalayas, right? Eroding the mountain, carrying the sediments, transporting the sediments along with it, depositing in Gangetic plains. So it is engaged in threefold task. One is erosion, transportation, and deposition. So exogenic agents, how many exogenic forces, exogenic agents we have? We have 5 exogenic agents. Which are they? River, glacier, wind, sea waves, underground water. River, glacier, wind, sea waves, underground water. So these 5 exogenic agents engaged in threefold task: erosion, transportation, and deposition. You will study in detail how they are engaged in what is the process, or what is the task done by each of these exogenic agents, where they are actually active, etc., etc. You will study in detail. For the time being, understand exogenic forces, they originate actually on the surface. They are actually engaged in threefold task: erosion, transportation, and deposition. They are engaged in leveling task. They are called levelers. So these endogenic and exogenic forces develops the important relief features which you see on the map of world today. I'll give you an example. See, endogenic force: earthquake, volcanism, mountain building. The forces which helps in the formation of a mountain, it is mountain building force. If we talk about Himalayas, which process helped in the formation of Himalayas? Endogenic force. After the formation of Himalayas, river started originating from Himalayas. River engaged in erosion, transportation, deposition. Understanding it? So Himalaya is actually what? The present Himalaya which you see on the map of India today, it is basically what? It is the resultant of 2 forces, action of 2 forces. One is endogenic, other is exogenic. Understanding it? Now come back to orders of relief. Second order relief. What is second order relief? Second order relief means relief features which are developed by endogenic forces. The relief features which are developed by endogenic forces, they are called second order relief. The relief feature which are developed by exogenic forces, they are called third order relief. So second order relief means relief features which are developed by endogenic forces. Endogenic forces develops relief features on land. Endogenic forces develops relief features in water also. Endogenic forces develops relief feature on land. Example, can you give me an example? Mountains, plateaus, right? So you can write mountains, plateaus. Endogenic force develops relief feature in water. You have example: ridges, trenches. Don't worry about these names. You will study in detail what is ridges, what is trenches in oceanography. At least for the time being, you might have heard about Mariana Trench. Right, trench, ridge, they are some relief features in ocean. You will study in detail. So what is second order relief feature? Second order relief features means relief feature which is developed by endogenic force. What is third order relief feature? Third order relief feature means relief feature which is developed by exogenic force. For example, a river. You know that river develops valleys, river develops deltas, river develops plains. So plains, deltas are examples on land, and exogenic forces don't develop any relief features in oceanic crust. Why? Reason is none of the exogenic agent act below sea level. Below sea level, none of the exogenic agent will act below sea level. If exogenic agent is not acting below sea level, then how they can develop what? Relief features, because then there won't be any third order relief features. Because third order relief features are developed by what? Developed by exogenic forces. So you will study this in detail, so don't worry. I'm just giving you a broad understanding with respect to relief. So we started our study with the geomorphology. Geomorphology is nothing but study of landforms, so different landforms on the Earth's surface. Any landform on the Earth's surface is the resultant of, or what are the factors controlling landform development? Two forces we have, endogenic force and exogenic force. These are the two forces which controls landform development. So relief features classified into orders of relief: first order, second order, and third order. First order, land and water. Macro division of Earth's surface into land and water. Second order, developed by endogenic force. What are endogenic force? Endogenic forces are variability developers. They have their origin within the Earth's interior. They will come out to the surface. They produce variations on the Earth's surface. Right? Third order relief features. Exogenic force, developed by exogenic force. Exogenic forces are river, glacier, wind, sea waves, underground water. Engaged in threefold task. Which are they? Erosion, transportation, deposition. Right? So endogenic force develops second order relief features on land. Examples are mountains and plateaus. In water also examples are ridges and ranges. I'm not getting into details of ridges and ranges. That is a separate topic to study. So just note down the example for the time being. Exogenic forces develops third order relief features on land, plains and deltas, and they don't develop relief features in oceanic crest. Why? Because exogenic force don't act below mean sea level. You have a clear understanding of this once you study about exogenic force. For the time being, understand exogenic force don't act below mean sea level. If it is not acting below mean sea level, there won't be any third order relief features. How many endogenic forces we have? 3. Which are they? Volcanism, earthquake, mountain building. How many exogenic forces we have? 5. River, glacier, wind, sea waves, underground water. What we need to study in geomorphology? We need to understand in detail 3 endogenic force plus 5 exogenic force. This is what you need to study in geomorphology. So we need to take up each endogenic force like earthquake, volcanism, mountain building. We need to have a detailed understanding with respect to these endogenic forces. What are they? What is the process? What are the characteristics? What are the important theories associated with it? Plus, similarly, 5 exogenic forces: river, glacier, wind, sea waves, underground water. But from UPSC perspective for prelims and mains, endogenic force, that is more important from GS perspective than exogenic force. But we should have a broad understanding with respect to these 5 exogenic agents, like what are the landforms developed by these 5 exogenic agents, like river, glacier, wind, sea waves, and underground water. So geomorphology is the study of 3 plus 5. Earthquake, volcanism, mountain building. 5, river, glacier, wind, sea waves, underground water. Right? Now, let us start with the first endogenic force. It is called volcanism. Volcanism. You might have heard about the volcanoes, different types of volcanoes. What is volcanism? You know that volcanism is an endogenic force. What is endogenic force? Endogenic force means force which has got its origin within the Earth's interior. Volcanism is the process by which molten rock material, magma, coming out to the surface. What is volcanism? You might have studied in school classes. Magma coming out to the surface. Magma is molten rock material. So volcanism is the process by which molten rock material, magma coming out to the surface. So the question is it only magma which will come out to the surface? Answer is no. It is not only magma. You have other constituents also being ejected out in the episode of volcanism. So ejected matter. If I talk about the ejected matter in the episode of volcanism, we have three types of ejected matter. One is magma, two is gases, three is pyroclast. Magma, gases, and pyroclast. If I talk about pyroclast, pyroclast is nothing but solid fragmented particles. Solid fragmented particles are called pyroclast. It can be dust, it can be ash. So many solid fragmented particles is being ejected out in the episode of volcanism. That is called what? That is called the pyroclast. What is the other constituent? Other constituent is gases, which is the most important gaseous constituent. The most important gaseous constituent is water vapor. Here you have ashes, dust, etc. Water vapor. You have other gases like sulfur dioxide or carbon dioxide, etc. But most important gaseous constituent is water vapor. Now coming to magma. No denial, magma is the most important constituent in the episode of volcanism. Magma is the most important constituent in the episode of volcanism. Magma are of two types: acidic magma, basic magma. Two types of magma we have: acidic magma and basic magma. So we are discussing volcanism. Volcanism is a process by which molten rock material, magma, coming out to the surface. It is not only magma. The ejected matter contains magma, gases, and pyroclast. Pyroclast is nothing but solid fragmented particles. Gases, the most important gaseous constituent. This was asked in prelims once. Most important gaseous constituent, it is water vapor. Now coming to magma, no denial, magma is the most important constituent in the episode of volcanism. This magma can be classified into two. One is acidic magma and two is basic magma. What is acidic magma? Acidic magma, if I talk about magma, two types: acidic, basic. If I talk about acidic magma has got more than 70% silica, and the basic magma has got less than 40% silica. Now, question is why silica is important. Silica is important because silica determines viscosity of magma. Silica determines viscosity. That means acidic magma has got more silica. More silica means more viscous. More viscous means difficult to travel. You know that volcanism is an endogenic force. Volcanism being an endogenic force, volcanism has got its origin within the Earth's interior. So magma coming out to the surface. If the magma is acidic magma, what happens? Magma has got more silica. More silica means more viscous. More viscous means difficult to travel. Difficult to travel means this magma has got more probability to get solidified within the Earth's interior. Understanding it? This magma is more viscous. More viscous means difficult to travel. So it will actually what? It will get solidified within the Earth's interior. Suppose this is Earth's surface, this is Earth's interior. Magma coming out to the surface. Acidic magma will get solidified here, here, here in different shapes, different forms. Understanding it? So why? Because acidic magma is more viscous. More viscous means difficult to travel. So difficult to travel, it has got more probability to get solidified within the Earth's interior. If I talk about the basic magma has got less silica. Less silica means what? Less silica means less viscous. Less viscous means easy to travel. So what will happen? This magma will easily come out to the surface and will get solidified on the Earth's surface. Getting it? That means we are talking about two important types of volcanism. One is called intrusive volcanism and other is called extrusive volcanism. The logic is very simple. Intrusive volcanism and extrusive volcanism. What is intrusive? Intrusive means within the Earth's interior. So magma is getting solidified within the Earth's interior. Intrusive. Extrusive, magma coming out to the surface getting solidified. So two types of volcanism. So now tell me which magma develops intrusive volcanism? More likely acidic magma. Why? Acidic magma is more viscous. More viscous means difficult to travel. Difficult to travel means magma will get solidified within the Earth's interior. That develops intrusive volcanism. If I talk about extrusive volcanism, which magma more likely gives us extrusive volcanism? Basic magma. Why? Basic magma has got less silica. Less silica means less viscous. Less viscous means easy to travel. It will easily come out to the surface, get solidified. That is extrusive volcanism. Right? So, see, if you understand the logic behind the different process, the geography becomes very simple, very interesting. If you start by hearting, mugging up the facts, figures, etc., it becomes more difficult, more boring. So geography is a semi-scientific subject. Geography can be tackled with the help of logic. So it is very important to understand the logic behind each of these geomorphic processes. So we'll talk about intrusive and extrusive volcanism in the next session. Thank you.